go. Let's go live on YouTube. All right. So, what have I done since last time? I haven't done very much on this project since the last time I streamed. But what we did do is check out what Brane. I figured out how to import functions to WebAssembly. So basically, in test script 1, we can say extern C, we have this public test external function here. And then we can call it from Rust as well. And what that looks like on the actual runtime side is first we read out the imports just so you can see what they look like. And then, we read out the exports, which we were doing before. And this is where we define the actual function to pass here. Now, the thing that surprised me is there's nowhere where you actually pass in the name for the function. Instead, what I think you're supposed to do is look at this list of imports here, and then provide this list of imports. You need to make sure that matches up to like the order of this object matches up to the order of the module you're currently loading. So they expect you to do all the building for it and then just pass them the already sorted data. So what we do pass to them is a function that takes 0 arguments and returns 1 value. Strangely enough, you can return multiple values in WebAssembly, at least with this runtime. And then we define a function type with args and return values. And then we add it to the store. So I think it's storing the actual memory address and whatnot in the actual WASM binary, or a way to call it. Or not WASM binary, but the WASM memory space. We pass in the type, and then we pass in the actual WebAssembly lambda. And this takes 2 arguments. One is a pointer to a value vector of arguments, the other is a value vector of results. Which is super interesting. So the data is, obviously we just do index 0 since you only ever really return one thing. It is interesting that it's an array. I'll have to look into the spec of WebAssembly. WebAssembly. Can you return multi-value is a proposed extension, but that's a proposed extension. The core WebAssembly that enables functions to return many values. Maybe the runtime just supports this in case that proposal goes through. Oh, I do have water. Nice. Anyway, so we set the data. And then this of, I think that's just a, yeah, it's a union. Oh, that's interesting. So we do wasm ref type for pointers. I guess that's for memory addresses. I'll have to keep that in mind. Does that mean I can define a function that takes a reference type? Instead of just throwing in an i32 value? Interesting. Results, data, and then we also have to set the kind of this or it bugs out. Oh, hey, how's it going? So yeah, we have to set the type, or sometimes it will freak out that we're returning the wrong value type. Like the first time when I didn't set this, I was like, oh yeah, it knows that I'm returning an integer. Because we passed in, you know, wasm i32 here when we were defining the function, so you know, I don't actually have to set this, but it's like, no, you're returning a... Oh, it is? Microphone is crackling a bit. It might just be because I'm maxing it out. Let me turn it down a little. Maybe, let's see, about there looks fine. Tell me if that makes it sound a little bit better. Built-in USB 2, audio, analog, stereo. But yeah, then we just say wasm func as extern, pass that into our imports array, and then pass that in here. Now, all this binding is making me consider if I highly doubt that it's not that I'm maxing out my CPU. I have like a Ryzen 9 whatever. Let's see. Because yeah, OBS is saying CPU is at 3.3. My bitrate to Twitch is fine. Sample rate 48 kilohertz. Audio bitrate is 160, which should be fine. I could, but this is the same. Here, I'll just try unplugging it. Let's see. That's interesting. I am seeing like little hitches in the graph as it goes up and down. I guess, is that better? Looks like it's a little bit quieter now. Do I still have the settings window open? I do. I don't think that would be it. Think it's fine? Okay. I've had mic issues every stream now. That's kind of weird. But yeah. So right now I'm trying to decide. We've got tests of all of our main things that we want to do all working. Aside from passing pointer datas in and out of, not pointer datas, passing pointer data in and out of this. That's the only thing we haven't tried yet. And I think from all the research I've been doing, you can't pass external host memory in because very sandboxed environment. So the only solution is to, from the host environment, write into the WebAssembly memory and then pass a pointer to that memory in the WebAssembly memory. So it looks like all our ECS stuff is going to live in the WASM store. We can still operate on it like a regular pointer for the most part, from my understanding. I haven't actually tried it yet. My question is, if we're going to be that closely tied to WASM, and I'm using essentially a Rust library with C bindings, do I just want to write the entire scripting system in Rust instead of trying to interface Rust with WASM that is interfacing to C? It might make it easier if we just use Rust on both sides with WASM as kind of like the in-between. But then again, it's just as easy to just use C on one side because, you know, we're using extern C regardless. And I would still have to interface with the rest of the engine. We already have the metadata parser as Rust. I guess the main thing I'm thinking is all of this stuff here, all the ECS is going to have to be, well, maybe not all of it, but at least the pointer types to our data is going to have to be changed to WebAssembly, because we won't be able to use native pointers. We'll probably have to use a handle type that kind of converts the call. Actually, can we get a raw pointer? I guess that's the question. And this is what we should investigate. Yeah, I think that's what we investigate this time. How do we pass memory in and out of the runtime? Right. The problem is the entity component system is kind of core to everything else. If I decided to go for native Rust for the scripting language, I would probably want to convert ECS as well. So going off of that logic for now, I think we keep using the C binding for this, as painful as that is. Yeah, we just keep on. Try to get to an MVP, decide where to go from there. I think that is the path from here. Because I really want to see some scripting in the engine, and as soon as we abstract a good portion of this, we will be really close to that. Theoretically. Theoretically. So I guess, let's... Yeah. And plus, this is C bindings for a Rust library. If we do want to eventually switch over to Rust, it'll probably just be a matter of deleting code, basically. This is true. I might do that. I'll probably keep certain things C++. I'm not sure. I figured out a workflow for meshing them over the past couple of weekends. So we can really do whatever we want with this. But yeah, for now, I cannot spell right now. struct. There we go. Test component. Let's try. Let's try actually getting component data in and out of WASM. Maybe not in and out of WASM, but at least accessible from both the host and from the WASM side. And hopefully, if we can just grab a raw pointer to the memory and then do whatever we want with it, because you don't need to sandbox the host from the runtime. You just need to sandbox the runtime from the host. So the host can probably reach his fingers in and do whatever it wants to. We just need to figure out how. Let's see, public A, we'll make this a bool. So do that. We have a little bit of padding that should be added in there. Because for the BindGen, well, for our C BindGen library to work on stuff other than this, so this is just me adding this in, creating my own standard, but this attribute apparently makes it so that the layout of the struct will be the same as in C, or the C standard if there is such a thing. Layout will be the same as in C. So I should probably check. Is it just in C++, do I just write a struct normally and this makes sure it matches up with that? I think for now that's the way that we handle this. So we have this component in here. And then how do we want to call this? Or test it out? So I think what we'll do is we'll return a test component pointer. Actually, I don't think it needs to be unsafe. We can just say after we say box new. Okay, yeah, it's not unsafe. I find it really interesting that the into raw and from raw are safe rust. Consumes the box returning a wrapped raw pointer. The caller is responsible for the memory previously managed by box. Oh well. So we'll say this is... That's true. It doesn't break any of the assumptions you have about memory, because this is going to be a valid pointer. It's not going to be a null. Then again, it's not even a... I guess that's another question, is drop always being called an assumption? I guess drop being called is an assumption, because I tried doing stuff with global static variables, and drop doesn't get called on those. Which I tried putting a save function in the drop method of a struct, or drop implementation into the drop trait. I don't know how to say that. Anyway. I tried to make it so when a static variable was disposed of, it would write out its values to a file. But yeah. From my understanding, you're basically just not supposed to touch it. We don't use static variables. And I mean, yeah, fair. Static bad. So go box into raw. I don't know. I guess my brain is going, oh no, there's a pointer. This means it's unsafe. But yeah. So we now have a thing for create test component. Let's do this while we're figuring out how to get memory in and out. So for the wasm unknown binaries, the print line macro doesn't do anything, so we do have to provide our own stuff for house. Oh yeah, that's another thing. How do we provide string output? Do we just say message is a constant pointer of U8s? I guess we can do some, say extern BraneEngine print. And then we can say pub BraneEngine print takes in a regular string reference and then returns a pointer to that. Question is, does Rust treat strings in the same way? I know there's the FFI string type. Right. And not null terminated. Okay, so we need to make sure that this is actually null terminated. So we're going to say let C string equal this. Let's say C string say C char here. C string dot I consume self. We want as pointer here. So this will be our print function that prints out to the console. It takes a pointer to a character array. So this will be one test. And let's add that into the test function. I wish I could remember like the exact processor I have, but the numbers always get mixed up in my head. But in answer to the question of what are my PC specs, Ryzen 9 basically the newest Ryzen processor. I can't remember the exact. Yeah, Ryzen 9 7950X3D. I can't ever remember that. 3090, 32 gigabytes of RAM, DDR5. Yeah, DDR5. So it gets the job done. We're gonna say BraneEngine print here. We're gonna say test function was passed. We're gonna say format. Just like that. So we now have a test print function. We don't have to worry about this yet, how that all works, but I do want to figure out how to print out to the console. That can be our first, how do we access memory from the runtime example. Because this, we will be passed a pointer. However, it's not actually a pointer. It's a 32-bit integer. At least that's what I think it is. But we can check. we can check. So let's compile this real fast. Then copy over wasm, create one wasm. Yep, we want to overwrite. And then let's run this real fast, even though it will fail, because I want to see. There it is. Wasm failed to compile module. Interesting. Do I have a... Do I listen to the reason why it failed yet? I don't. Okay. So we need to do that. So where's somewhere else where I error check? Okay, yeah. Was an error message. So you're gonna say module error. Or maybe we don't have to, we can just say Wasmer last error, and that might be able to grab it. Because Wasm knew, okay, this actually doesn't have a pointer for Wasm traps. So this last error hopefully contains the actual reason. Memory 64 must be enabled for 64-bit memories. Oh, did I accidentally turn that back on? Target, oh, it's because I went into the Wasm 64 build that I was testing out there. Sadness. I really wish that I could just start development with the 64-bit target, but Wasmer doesn't support the 64-bit target yet because the spec hasn't been fully completed. And I am in a couple threads asking about like how I could maybe help implement that and whatnot. But for now, we'll be building with 32-bit Wasm, and then the instant 64-bit Wasm becomes supported. We are on that. Okay. So now we get the instantiate. The extern BraneEngine print, incompatible export type. Oh, so it actually asked for print first. That's interesting. I know. This is pointing only for... And that's why I was a little bit like, oh no, we have to keep all our memory in Wasm because we're constrained to 4 gigs at the moment. Which, to be fair, you know, that's a hell of a game if you have 4 gigs in memory. And we don't have to have, obviously, 3D models in Wasm or whatnot. So models and textures, we don't need to have that in the Wasm runtime, which will clear up a lot of space. We only need to have code and the entity component system in the runtime at any one time. So that shouldn't, for now, shouldn't be a bottleneck, but I could see it in the future, like, if we try making an open world game with a ton of unique systems, I mean, we probably run into CPU bottlenecks trying to go over 4 gigs of entity component system. Long before we ever get to, you know, memory bottlenecks, but it's still like, I don't like having that limitation. I have 32 gigabytes of RAM. I want to use all of it. We have these resources. Let's use it if we can. It should still be able to run on lower end hardware. Like, I would love if this runs on a Quest eventually. And this is a benefit of this, is it would run on a Quest. But yeah. Okay, I think at this point we want to start thinking about abstracting functions. Though I really do want to get all of the proof of concepts before we start abstracting. But we are starting to reach the point of we need to start doing abstractions. Because we're gonna need to do all of this again. So we're gonna say test external function. Just because this is gonna be ugly. But since I don't want to have to rename tons of variables and have them clash with each other, what we're gonna do is this. And then for our second function export, we're gonna do it again. So we're gonna say this is BraneEngine print wasm func as extern BraneEngine print, and I'll come up with a better name for the actual API we end up shipping to people. But for now, this is what we have to deal with. And we're gonna put BraneEngine print here. So we do actually have arguments and we don't return anything. Okay, we're just at the end of a song. I was confused there. I was like, where's the music? I just realized I never initialized args. Oops. But what we can do is say, yep, that is return, and we're gonna say args1. And what do we have to work with? I32, I64, float 32, float 34. Wasm anyref. We might want an anyref here. Wasmer type for pointers. I guess I can actually look at this. Results. Oh wait. Parameters 1i32. Okay. So we take in an i32. Can we say any ref and this will still work? I think it needs to be an i32 for now. So we're gonna say args This is the wrong function. BraneEngine print. Our arguments take one 32-bit value. We shall assert that arg's size is equal to 1. Arg's is a WASM i32. And now we have the fun of do we have a way to access the store? Or do I have to static variable this? Can I take... No, it's a raw function pointer, isn't it? It's like, can I make a capturing lambda? Because we take in a wasm function callback. But no, this is just a type def raw C pointer, so we can't do any capturing args. But we can do function new with environment, which I believe is what we want. Which takes a wasm function callback with environment, which takes a void pointer to whatever environment we want to pass in. With environment. And for now, we're gonna say, we're gonna pass in the store as environment. So we pass in the store, the function type, and then, okay, the environment is the last pointer we pass in. So we're gonna pass in the wasm store. So now we have access to the store. Function type, callback. Oh, it's literally the last, and then we have a finalizer. I'm guessing this is a cleanup function for the environment. So we pass in store after here. And then this is where we would do cleanup if we were just passing in some random object. Don't need to worry about that for now. We can just have an empty finalizer. It is cool that they have this though.
I'm sorry to interrupt. I have need to show.
Indeed. Don't eat
Optional.
Don't eat thermal paste. Optional. It's true though.
You're welcome.
Thank you. All right. So let's see if they have any documentation on the right way to do this. In the C++ bindings, not in the Rust bindings. Maybe we can get some Wasmer. I can't spell memory. Host functions accessing memory. host, I can't spell. So I know there's ways to allocate memory. Memory that WASM can access as per WASM spec. WASM linear memory can be imported or exported by a given WASM mod. Imported WASM linear host. Exported WASM linear can be thought of as being created during the WASM instantiation. Okay. If I said WASM let's use some IDE tricks, because I think if we do that, it will give us functions that we pass WASM store to as well. Function new with environment, environment new, foreign new, global new, instance new. We don't need any of these news. And store doesn't have any variables. It'd be nice if it just had a data variable. It's like a raw pointer to the data. But I don't think it does. So that's how we allocate memory, is this WASM memory new. WASM ref as memory. I'm gonna say memory constant for now. And then we're gonna say args data 0 of ref. WASM ref type. So this will access it as a pointer. Which I don't know if that's the correct way to do this. However, extern BraneEngine print, we ask for a C-type char pointer. It's taking an I32. Because this is going to be a 64-bit pointer. Do we just treat it as a 32-bit pointer? What is the FFI standards, or whatever it is? So we can say WASM memory data. So it's like super easy to allocate memory and then access the raw data as a raw byte pointer. That's amazing. Wait a second. Wait a second. Do we have to say heap base? And that's our reference point? What? No, but those are globals. They're not the actual memory itself, because this is where we start and end in the WASM allocated memory. Export 0 memory. That's our memory. So if we said okay. So maybe we don't want the entire data store. I feel like we would. So is this module already connected to the data store? Here, yep. WASM module new. And we pass in the binary, so this is already on the store. So the memory export. I just need some documentation. Okay. So we say memory. Get export memory. Okay, interesting. So it literally is just that was the general direction I was heading. So where, okay, exports. We're gonna say WASM memory type. This is our memory. If this export is simply called memory, literally just lowercase memory, then we're gonna set memory equal to WASM extern as memory def. Well, actually, this is just the export type. So we'd say hello, how's it going? Next turn is memory. We were just getting export types. How do we get the export itself, not just the export type, though? Doing good. How about yourself? Just doing some three different language runtime binding between all of them. So we're already grabbing the exports. We're saying, okay, if this is the memory export, was a module new. I wonder if it has something to do with the data store. That's what people tell me. I don't know. I just sit doing my own thing, and if people want to watch, they can. Wasn't. Let's turn off Copilot for now, because we want to actually see the editor options. Wasm, and then so right now we're attempting to make the scripting runtime for my engine. So I was trying to make my own scripting language and everything, but it was just taking forever. And I actually got it pretty close, but I was just a little bit worried I wouldn't be able to make it as secure and stable as I wanted it to. So I switched over to a different route, which is using a WebAssembly runtime for scripting instead. So right now we're just exploring doing that. So currently we've gotten all the way from having Rust test scripts, so you can just say system over a function, and that defines it as like a system for an entity component system, which is the architecture I'm going with for the game engine. And we can put component over structs to define them as components in the entity component system. And then we compile this file to WebAssembly, so you can see our WASM crates here. And then finally, this isn't actually connected to the engine yet. We just have this WASM scripting tests small command line executable that we're just using to test stuff. What we're doing is just loading that WebAssembly module and testing how we call functions from it. And right now, the very specific thing we're trying to do is getting this print function to work. So where is it? This test function here, we pass in an integer to it, and then we just return the integer. That was my test of, can we put data into a function and can we get data returned back out from the runtime? Success, of course. This was my test of calling a function we import from the runtime and everything. And then right now we're testing, okay, can we pass a WASM pointer to the host? So all of this is, what's the term for it? It's like in the WASM runtime, and then the function running that runtime is called the host. So we need to pass this pointer from the runtime out to the host, and then have the host look into the runtime and go, okay, what does this memory actually mean? And then to answer your question from Twitch, is this a via WASI compliant runtime? I'm not doing WASI. I'm just doing raw WASM at the moment. The particular Rust target I'm using for this at the moment is WASM32 unknown unknown. I would like to be able to use the 64-bit target, but the runtime I'm using currently doesn't support it, and the standard isn't standardized yet, so it's not. The standard isn't standard, therefore it is a paradox and does not exist. So basically, I can't really use it yet. It's only on the nightly build of Rust and all of that fun stuff. So for now, we're going to build out in 32-bit and then switch over to 64-bit the instant it. So right now we're using Wasmer, which is just... So it's actually a Rust runtime, but we're calling it from C++ because, you know, we want to tempt fate. But yeah, here's their GitHub. But yeah, you know, blazingly fast and secure and all of that. But yeah, bindings to every language. I might eventually rewrite this entire engine in Rust. I haven't decided yet, but I have like 2 years of work in C++, so we're just using C++ for now. But the script, so the engine itself is in C++. The scripting runtime is in Rust. Which leads to weird stuff like, where is it? Right here. So I have like this module metadata parser module here that I'm using to extract, to manually parse the files and extract data about them. And we have a CMake and cargo toml file in the same folder, which to some people might be considered a cardinal sin. I don't know. I like tempting fate in that way, though. It's fun. It does support those two, yes. At the moment, I'm trying to keep it as locked down as possible. You know, start with a little bit, and then obviously it's pretty easy to just flip the switch from Wasmer to Wazi. I do want to keep it as sandboxed as possible, since the idea behind the whole game engine that I'm building is that it's something that would be downloading stuff from the server, from a random server at runtime. So, you know, you connect to somebody's server, download their game as you play it. So, you know, you walk around a big open world and you only download the part of the world you're in. But we want that to be secure, right? So I think Wazi is still probably secure. I'm just being like super cautious at the moment, to a probably unnecessary degree. And plus, this is easier to understand than going into the whole Wazi stuff. Anyway, back to what I was doing. How the hell did we get a pointer? So we somehow need to grab, oh yeah. We somehow need to grab this extern. This is asking for a wasm extern. However, when we ask for the module exports, all we get are export types, not the actual exports. So I guess, well, I don't really have any guess at the moment, but if we just said let's just see everything that has extern in here. So these are all conversion stuff. Extern as whatever, extern, extern vector. Named extern unwrap. Maybe that's what we want. that takes in a named extern, which means we would already have whatever. See, the problem is I'm always dealing with like super new stuff, so I don't know if GPT would know. Because it's like, can't remember if it's 1 or 2 years behind. I think it's only 1 year behind. So it would have heard of this, but not any of the latest bindings. And there's no, like, almost no public documentation on the C API. So we're just, you know, raw dogging it, you know? Module exports. So this gets the module exports, but they're export types. Which of course is opaque because it's from Rust. Maybe. So let's look at the Rust version of doing this. So this just caller get export, and this is a WASM context or WASI context. So maybe well, that's the thing. We need to pass the function. We need to pass this function into the instance to actually have it work, but we might need the instance to get the export. So it's like a catch-22. Wasn't it get start function? Instance as ref, instance at host info. Instance exports. So that gets, so I'm guessing this is an instance of a module, not an instance of the entire runtime. So I guess I could have multiple modules on the same store. Okay, which means that unfortunately I do have to make this, at least for the time being, because I'm just doing a proof of concept. We'll say WASM memory is null pointer. Say instance memory. And then down here, what does this take again? WASM extern vect. Equals WASM instant, oh, vec new. Actually, does this take a pointer to, okay, yeah. I probably don't need to initialize this. I'd probably just say instance exports. WASM extern vec, WASM instance. That is a pointer. Oh, I had that as a pointer. Okay, there we go. In many different ways. How is it different from? How is BraneEngine different from Unreal? It's built with a different sort of game in mind. So, the term I use for it, or I've just kind of come up with, is asset streaming game engine. So the idea is that the entire engine is optimized around loading only the pieces of worlds that you need, whether that be over the network or from disk. So I totally might ship games as a local binary, but then, you know, you're just like emulating a server or whatever. But the idea is basically long term, it's an MMO engine, like VR MMO engine. That's like the super endgame goal. Not doing that right away, that's like 5 years into the future with a big team, if it gets to that point. Possibly a lot more. But right now we're just trying to make like basically get to something like a VR chat room where you can just have a couple people stand around. That's like the current short-term goal. But then even shorter, we're just trying to get to like a Pong demo where, you know, you log on to, you open up the client, you type in whatever IP I've set up, and then you just get Pong, and it's like multiplayer. So the difference between BraneEngine and Unreal is that Unreal exists, has much better graphics, though we do have PBR shaders. So, you know, we're not, you know, complete scrubs, but I guess engine focus is the best way to put it. We're not focused on like AAA games. We're focused on people hosting their own stuff, communities, whatnot. It also doesn't exist yet. Like, we're writing proof of concepts for the scripting system. You know, we can't write custom behavior without hard coding it into the engine at the moment. So, what was I doing? All right. For I is less than instance dot size, and then we're just going to say export okay, what is instance exports? Right, it's a it'd be nice that if they had like some sort of compiler runtime that actually expanded these so I could look into types and actually know what they are. Let's see. So we're gonna say export is instance exports data I. Oh, we can't because that's a thing. So then we get a wasm extern t. So I'm guessing the function for the name would be something like wasm extern name. How do we check if they're named exports or not. What type of games are you looking forward? I'm guessing the most to be used on the engine. Stuff to do with open worlds, to be honest. Large, beautiful environments is what I want, like spectacle. There's not enough mega structures in VR. It is like a VR-focused engine, or at least it will be once I import anything to do with VR. At the moment, it doesn't actually have any VR functionality whatsoever, because we don't even have scripting yet. But yeah, in the future, open world VR games with really cool mega structures. So we have all of the exports. Oh, I already grabbed the exports down there. So let's go down here. Externs. Wait, I probably have to do this the same way I do with this. Int test memory index. Just like that. So we now have the index of the memory extern, which is probably 0, let's be completely honest. And then here when we get the externs, we're gonna say instance memory is equal to wasm extern as memory test memory index, just like that. So now we have our instance memory, which means all the way back in wherever we define the callback. Here. So we don't need to pass the store anymore, so we don't need this to be new with environment. Since for now we're just using a static variable because we're lazy. We're gonna say memory is, this isn't what we want. Module data is equal to wasm memory data, instance memory. And then we're just going to print out for now module data at this index. Because I think the way the pointers work in WebAssembly is they're just the index of memory in the entire exported memory. Because I don't think we can handle multiple memories at the moment. But instance memory, get the data for it. then it's already a character pointer. And then we're also going to say, get the reference, because we want this to be an entire character array. And let's see what that does. So we pass in BraneEngine print first, then the test external function. Eventually we do want to do a name-based map for this. Look at that. Test function was passed 42. That print statement was from here. So I guessed correctly. Woo! Baby, that's what it's about. That's what I'm going for. Woo! So, that's amazing. We can just get a raw pointer to the data. That means we can literally just grab the data pointer. Question is, not much. What's up with you? We just figured out how to use pointers passed to the external runtime. So basically, I defined this BraneEngine print function, made a little bit easier API for calling it. We actually call it in our test function. We say test function was passed, and then we put in the value that we were passed. And then it actually prints out. So over here in the WASM scripting test, this is the actual function that gets called there. WASM memory data, and this is the data we got. So for the entity component system, we can in fact grab pointers, which is amazing. So this is how we grab that. I guess my main question now is what happens if this pointer changes? So if we call WASM memory grow, we can grow it a certain number of pages. And then obviously the memory would be somewhere else. So we need a consistent way of telling when WASM memory grows or shrinks. So this is WASM time. That's a funny question. Why are all the super popular WASM libraries in Rust? It makes sense. Rust is a good language, but it's interesting that all the WASM stuff is in Rust. WASMer is run by a corporation that runs the package manager. Well, WASM Time is run by a nonprofit. I might actually want to switch to WASM Time then. Since they both use the same backend. That function, not function, sentence doesn't make sense. Since both compilers use the same backend, the performance for WASM Time and WASMer is noticeably different. Wouldn't they look the same if they're using the same backend? WASMer, WASM Time, it's a lot smaller. Just starts up slower than native code because they need extra time to load and compile the code before running it. Both cache the results of JIT compilation. Yeah, the cache files are opaque blobs for both runtimes and are only named. For WASMer, we can clear the cache with clean cache. However, WASM Time doesn't have a way to tell it to clean the cache. But it does have some settings for how the cache is managed. Deleting files by hand makes it shrug and recreate them. Both WASMer and WASM Time are easy to embed in Rust programs. Okay, this doesn't really tell me anything. Like, okay. Build with native code. .3 seconds. So from the sound of it, they're both written in Rust and both written with where was it? I think it was Crane Lift for the backend. Crane Lift, formerly known as a creatone, is an optimizing compiler backend that converts a target independent. Oh, so it's just a compiler. So yeah, both of these are written, at least the runtime. The library you interact with is written in Rust. So like WASMer, if we go to their GitHub, I don't think I still have it open. Yeah. WASMer, 94% Rust, 2.7% C++. If we go to WASM Time, where is, like, here's their Rust docs for their library. If we go to their GitHub, here's Wasm time. 70% Rust, 19% WebAssembly. So yeah, both of them are primarily Rust. I liked the look of Wasmer because it does have an LLVM backend that you can turn on. And it also has this thing where you can compile, you can ahead of time compile your Wasm binaries to a native like .lib file or .so file. And then, from my understanding, you're able to also cross-compile that. So you're able to have this ahead of time compiled native binary and then drag that across to say something like Linux. So you have a .lib you ahead of time compiled on Windows. Bring that over to Linux and cross-compile that into a Linux binary. And then you're just able to call stuff from that, from their sandboxed runtime. Theoretically, you could do that with Arch and everything as well. So I like that versions of Wasmer. Does Wasm Time have the same stuff? Because I do like the idea of an open source package instead. Especially if their C API is better documented. That's already a lot more promising. This is like nothing, but that's already a lot more promising than Wasmer. It's like the same exact data structures. This, okay, that's Wasmer. Where was the Wasm time? Did I close it? No, there's Wasmer. Where is their GitHub? There it is. Bytecode Alliance, Wasm time. Fast, built only optimizing crane lift code generated to quickly generate. Oh wait, there's an official C API of Wasm. Wait, so you're saying this BS I've been having to deal with is the standard? Oh joy. That's why they're the same exact data structures. It's because it's the standard. Okay. It's a BS standard. Joy, and they even used the whole Wasm defined type. So this stuff is part of the... Of course it's part of the standard. But what if I want to be able to see what a data structure looks like instead of having to guess it from IDE stuff? I guess, do they have docs? Do you have docs? I'm not seeing any docs. For interfaces, see example. Okay, yeah, we get example uses. Well, I basically figured out everything I need to. Wasn't time and wasn't there. I think I stick with the Wasmer for now, though, just because they do have the ahead of time building, which is something I want for the engine. Double check. MIT. Okay. I was like, okay, yeah, MIT. Even though it is a for-profit company, it is still MIT licensed, so that's fine. I mean, I work for a for-profit company making it open source. To be open sourced software. It's not open source yet. We are working very hard to try to get to that point. But yeah. So we'll stick with this. We'll deal with the fact that the C API, the standardized C API for WebAssembly, this is the standard. The standardized WASM. Okay, we do include wasmer.h. There's a wasm.h file. It's compatible with the wasm C API, standard API, wasm h. Okay. I guess one last thing, we'll try passing a test component from the runtime. See, we're up to nearly 400 lines of code here. Let's see, where is our, there it is. Int test. We're gonna do test component access index. And then we're gonna have this be test component access. And we're just gonna return the test component. Just return the component. I'm gonna say component is equal to test component. Just gonna delete that for now. Set this component to be equal to this. Then we return the test component. And to make this indeed safe, if component is null, we'll just return component. Is null safe or not? Not sure. It is safe code. Okay, we'll just plop it out of there. So all this code is now safe. Unless we get a invalid pointer that's not null. In which case, it's out of our control. We will crash. Okay. Actually, we could do this without any unsafe rest, I think. Nothing's really wrong with Wasmer. I don't know. I just had a random side tangent where I was like, okay, let's look at the other runtimes for WebAssembly code. Honestly, I don't know what brought on the episode. I was just like, oh, let's look at WasmTime. So WasmTime is like, there's Wasmer and WasmTime, and those are like the two, from what I can tell, two big WebAssembly runtimes. And then there's V8, which just exists, but V8 is also a JavaScript runtime, and I don't want to touch JavaScript, so that's an immediate no. Because I think V8 is, you're using JavaScript, and then the JavaScript loads loads the WASM binary through whatever standardized JavaScript systems. Okay. So we'll just test if we can pass a component into here. If we're able to access all the memory as we should. And then, yeah. Let's see. Component equal, just wondering, from raw component. Is this unsafe? Okay, yeah, that is unsafe. I'm just gonna do this for now. We don't need to convert it to a box. Okay, let's compile this. We'll go up here, grab that. No, not the debug file, grab this. Plop it in there. Then I think let's switch up the audio. Okay. Now back to here. Now that we have our test function or whatever, oh, perfect. Actually, so we grab our text component access. I'm actually going to start scoping these. So that I can call them with the with the same names. Don't ever copy this much code. That's a sign that you should be modularizing it better. So we're gonna say text function is equal to test component access so this takes in an int and also returns an int. How do we allocate some memory? So our arguments, instead of 42, we want to pass in our test component. Say wasm memory I guess we don't really have a malloc function, do we? We don't have a malloc function. Which means... You can either let wasm create the memory and export it, or let JavaScript create the memory and import it. How do memory imports work then? Okay. So the most reasonable solution I can see is that we just need a way to allocate stuff on the WASM side. I wouldn't do it. So you would need to do So I need to come up with a standardized way of allocating memory on the WebAssembly side. Which is very interesting, and then pass that back to C++, instead of just allocating the memory on the C++ side, like a sane person would expect you to be able to do. Or we figure out a way for this whole WebAssembly module to import memory. Feature WASM import memory. With this attribute, the WebAssembly module will not export its own memory buffer, but instead import the memory from the environment, letting the caller set it up. In the future, it will be possible to use a shared array buffer in order to share memory across multiple arrays easily. Which is probably what I want to do, to be honest. Does nothing but returning the data passed to it with some allocation functions. Because yeah, I don't want these modules exporting their own memory. Instead, I want them to be able to, communicate with each other. So if I said if I use this WASM import memory, feature may not be used on the stable release. Cannot find a declaration to go to. That checks out. Oh, so this thing on the page was passed through WebAssembly. That's cool. This is one special attribute. So where does WASM import memory come from? Oh. So you need to pay for the course, but you can access the transcript. Oh, this is raw WebAssembly. The human readable context. Which doesn't help us too much. Doesn't help us too much at all. So how do I create memory in the host environment and pass it back? Because I want multiple scripts in different modules to be able to access the same API and receive pointers. The pointer part of that is important. Hmm. Okay. Where does this import memory attribute come from? Nope, we're not gonna go with laws unpack. Looks like they're setting up a different allocator though, which is interesting. So if I ever wanted to create my own custom allocator for Rust, for these, I guess I could. So yeah, there's the game of life going, which, well, that's kind of cool. They have a factory going. Okay, if we said we were using nightly Rust, if we said nightly, oh, would this work? Build target wasn't unknown. Of course, the standard library is missing. Can't remember the command line args to manually build it at the moment. But if we ran cargo check on this, Hey, thanks for the follow. See, cargo nightly check. I guess it's the feature. Yep. For the attribute macro system, that's to be expected. Actually, it's not to be expected. It should be fine. But yeah, it's not finding the WASM import memory feature, so that just doesn't exist. Linear memory. It's a contiguous buffer of unsigned bytes that can be read to from and stored by both WASM and JavaScript. Like WASM BraneEngine, which is part of the WASM pack workflow. Between Rust and JavaScript, we're writing our own version of that. But for this example, we will simplify buffers and pointers and show off the concept. Which means we will have unsafe code. So static mutable WASM memory buffer, which is this buffer size. Okay. It's not a resizable buffer though, which is what I would want. Yeah, I've already tested stuff like that. How would I import the memory though? Build, release build. You can also have create your executable. Yeah, there's the stack pointer. We have the memory. How do we import memory? I want to import memory. I guess what we would really have to do is load two modules and see if they can access each other through their pointers. So you want to say no mingle. Yep, I already know that. Importing. Oh. I am putting a bookmark here. You can even set the export name of function. That's really cool. Ensures that code running in the WebAssembly VM gets no access to anything in the host environment, apart from the functions that would explicitly passed into the sandbox via the imports object. Let's say we want to create random numbers in our Rust code. We could pull in the rand Rust crate. Why ship code for something if there's already something in the host environment? As a first step, we need to declare that WebAssembly module expects an import, which is this random. And we can actually link wasm import module math. The imports object is a dictionary of import modules, each being a dictionary of import items. In our Rust code, we declared an import module with the name math and an export function called random to be present. Interesting. I'll have to look into, well, let's actually just check now, because I think we fulfilled all switch cases. So go back to wasm scripting tests, so all those go away. So there's a extern global, extern function, extern memory. Would the table be what we're looking for? So I wonder what, if we said link wasm import module. In test script. We said wasm import module. And we said that this module was BraneEngine. So we're expecting these from BraneEngine. Would that even be safe? I didn't see when you sent that, so I'm not sure exactly what you're referring to. But having two of them access each other's memory. So not their memory per se, but I want all of the wasm modules to be able to access the entity component system without copying all of the data for every single call. Well, even evil shadows have to worry about their data safety. You know, if they aren't safe about their operations, the world will know about their evil plans. But I don't necessarily want all the modules to be able to access all the other modules' memory. But what I do want is for everything to be able to access the entity component system through an API that returns pointers. Because copying struct objects is far too expensive for a game engine. if we could come up with an efficient way to only expose one bit of, like, one section of memory, then that would be better. But for now, that's kind of like our compromise. Because there's no way for us to pass in host functions. So we basically need a way to import memory at the moment if we don't want to just have having to copy a separate copy of the entire entity component system into every single module instance at the moment, because that's what we would have to do at the moment. Okay, I just want to see what this does for now. Or if we compile this. And then, so we'll copy. Paste that. No, we don't want the debug file. We want the WASM file. Brain farted. We want that. Overwrite. Yeah, that's my plan at the moment, is to make all of the memory for components in the WASM memory. The problem right now is, at the moment, there'd be no way to do that for multiple modules at once. Right now I'm trying to figure out how do I expose that memory to all of the modules. Which, of course, yes, there is problems with that. But, like, what if one module is messing with everything else, and etc. But for now, I just need to figure out something that works. So if we do this, WASM memory was not declared in the scope. Do you mean WASM memory T? When did you exist? Oh, it's because I was doing the whole component and I couldn't figure out how I would allocate it. Okay. So it's still I'm not seeing import module doing anything at the moment. That might be more of like a might be more of just a JavaScript thing. Yeah, higher level types. How do we import memory? I want to know. I know it's possible. Right. Yeah, that is a possibility because I already have ECS mostly working on the host. Well, theoretically fully working on the host. I just need a way to expose the memory. Memory management, of course. Well, we don't need to give up the standard. The target works. Okay, I guess first we can check if Wazimer supports shared memory. Is it bulk memory? I think bulk memory is mostly to do with bulk memory operations. Awesome. Bulk memory. Yeah, it's bulk memory operations. Right, but there's not really a easiest thing at the moment, because at the moment the easy thing to do would be to have an entire copy of the entity component system for each instance of a module, because for the instance of our print function, wherever it is, what we have to do is get a pointer to the current instance memory. And where we get instance memory is it's a extern exported by the instance of our module. So our module is what's giving us the memory, not the runtime as the whole. So what that's telling me is that if I had two modules in here and one wanted to interact with the same memory as the other module, that wouldn't work, which means this print module, that print function would have to be this different for every single module. We need to pass in, okay, which module are we currently using, grab its exported version of memory. Be a lot easier we could just use one memory buffer for all of them. And if we figure out how to share memory, possibly we also figure out how to do unshared memory. So it's possible that modules would be able to define what memory they want to share and what memory they don't want to share. Memory. Which goes back to here. I got distracted. Features. What's multi-memory? Rust and WASM's multi-memory feature. Rust continues to be a first-class citizen of the WASM. Is the multi-memory proposal? Let's take a look. It's a clone of, yep. This proposal adds the ability to use multiple memories within a single WASM module. In the current version of WASM, an application can already create multiple memories, but only by splitting things up into multiple modules. A single module or function cannot refer to multiple memories at the same time. Consequently, it's not possible to efficiently transfer data from one memory to another, since that necessarily involves an individual function call to a different module per value. So yeah, this is the problem I was talking about, where a module may want to separate public module memory from private memory. Even internal, it's supposed to be able to separate memory, like to isolate between threads and whatnot. So multi-memory looks like it's what we want. So going back to this form, it does have okay. So you need to code directly in Watt to get that working. So I got super far on BraneScript, but I'm just worried that I won't be able to have something as stable and secure as I want. And WASM is essentially exactly what I wanted to build with BraneScript. I mean, BraneScript was theoretically like 85-90% of the way there, but that last 10-15% was taking forever. So exploring this as an alternative. Attribute express space extension. Okay, so multi-memory doesn't look like it's implemented in Rust yet. Multi-memory. No multi-memory at the moment. Alright. What about reference types then? Easier and more efficient interop with the host environment. Allow host references to be represented directly by type. So I guess when I started kind of this experiment of could we use WASM, I was under the impression that this this store object was what all of the modules lived inside. That they would all use the same memory, but it seems like they all export their own, like, this is where my memory starts sort of deal. Making it pretty much completely impossible for me to create the type of systems that I want. Because this instance has its own exported memory. Okay, so this just is the two features. Is this WASM import memory? Not exports. So theoretically, this would just magically make it work. The problem is that one, its feature, meaning it only works on the nightly branch. Two, it's just not showing up at all. See, I believe there's a build standard. Yeah. Okay, so if I said cargo nightly, build a target WASM Z build standard that we don't want to release. Okay. So it's still not finding that WASM import memory feature. And it's also not able to determine the resolution for my own macros. Which is weird. Which is probably just because these aren't working either. The question is, where is this guy getting this from? Where is feature wasn't import memory? Oh, do I have to use some LLVM tools? I could use some LLVM tools to recompile some stuff. I'd be fine with that. But there's also the LLVM stuff to strip out unused data. Okay, is this binary yen? So what is this? For WebAssembly. Okay, so this is what we're using on the back end. Okay, what if I tried... Well, I don't want to link it immediately. WebAssembly dynamic linking API used by Inscription. Position is determined by the I haven't yet. I could. I don't think it would. I'm pretty sure it wouldn't work. But, I mean, if worst comes to worst, we can just try. It's interesting watching the year numbers tick up on this blog post and stuff slowly start working. Though I am worried we're getting near to the end here. So looks like they had some success as long as they didn't have static variables, which I'm perfectly fine throwing away static variables. If we say link args, like that. feature link args. Okay. Yep. Then the build scripts, which I did think I set that to the nightly channel. Okay. So if we try compiling this with the nightly, there's we get this same cannot determine resolution. Feature has been removed. I'm gonna try a little bit longer just to see if I can pass, well, link args. Argo linker args. Can say C link args. Yeah. So that's in the config files, not in the project. Kind of library and modifiers can also be specified in a link attribute. Specifies the name of a native library that the compiler should link with for the items within an extern block. Okay. Per binary linker arguments. And that has been stabilized. Rust C, C dynamic link args. Okay, so that might be somewhat what we're looking for. So if I said C link arg, and we went back over to here, we said import memory. I think we can do multiple of these, because I think we were able to do multiple Z arguments. This is just shared, right? Okay, both of them were double dash. Shared and import memory. Unexpected argument C found. Okay. It's because I did multiple? Maybe after we put it before Z. Okay, so it's still not liking that. So maybe we do put it in a build. Okay, so let's try it through build script. So here we say new Rust file. See, what was the syntax for build script outputs again? Okay, so we do have the cargo thing. So we can say, what were our two variables? Port memory. And also I think link arg singular. So I believe we can just do multiple of these. And they'll get added. Okay, let's no longer do nightly because I don't think, because we were just doing nightly for the arguments. Error creating shared libraries with shared is not yet stable. Looks like we're going back to nightly. Oh, that's right, it is here. Not found in this scope. And for nightly, we need to build a standard library. Failed exit status 1. Cannot link with shared, which is not yet stable. Okay. We may not need shared at the moment. So let's try it without. So theoretically this worked. And it didn't complain about there being an unknown argument. So our import memory flag might have been used. Let's check. Let's see an error. I'm seeing an error. Found 3 imports. Import 0, memory. Let's go. Woo. Okay. So, we actually do have an import from memory now. And export 0 is a function. We no longer export memory. This is exactly what I wanted. It took far too long to get here. Type -1 pages. All right. So I guess the shared flag for now, we don't have to worry about. Since it's a lot easier to create bindings and replicate, it'd be a lot easier to automatically link up functions we want to share between modules just through importing and exporting them and then having some boilerplate code connect them than having to manually copy memory over. So, all right, let's test this out. The question is, will this automatically resize itself, or do I need to keep tabs on? Actually, here, let's see what I'm doing in allocating memory. This print statement does not line up with anything. Okay. So we don't need to enable multi-memory or even modular linking yet. We're not using that. So let's make instance memory. Well, we still do need it to be global so that our lambdas we can pass state to lambdas. Were I rewriting this, this wouldn't be a global. But for now, we'll keep it as a global. Wasm memory new. So let's check out what WASM memory type is. WASM limits. Minimum and maximum. Okay, so we're just defining. Are we defining how big we can, like the initial value and then the max value of a memory? Or are we defining the actual range of this memory within the module? Because I feel like that's just the range of what this buffer contains. I'm just clicking around randomly. Let's see, so WASM. So can I say engine? So that we can only create a new store. So let's say, what can we do with a store? Well, we can create new memory. Let's look at the standard. Memory. So we can say new, 1, none, false. See, this is a memory type. Pages. So they said 1 page minimum. And the maximum was the maximum number of pages. And there was a none option. So okay. So we don't have to manually set how much memory we want right away. This memory is growable. So, yeah. WASM memory new. And then we want WASM memory type. See, is there a WASM limits new? Okay, there isn't. So we'll just say WASM memory type limits. Oh, this is a function. It returns a WASM memory. Oh, just WASM limits. Type instance memory limits minimum 1. So I guess what would our value be for none? Would I just say 0 here to say there's no max on this particular memory since it's our core bit of memory? And then we'll just say memory type new, instance memory limits, and then I want to set this to shared. Declare okay, so this doesn't have any way for us to set it to shared. Oh, instance. We want the memory type here. So we can, as an extern type, we can copy this, we can delete it, extern type const or limits. So there's no way to define it as shared, which is what I want to do here, which in the native Rust bindings, there's a way to do that. So yeah, let's pass in instance memory type. Shared. So these are the only 3 references to shared in the entirety of WASM H. And there's no one Wasmer at IH. So we don't set the memory to be shared at all. But we do have instance memory now. And the first import is memory. So in our imports, let's throw in memory and see what happens. Memory as external. There we go. And then this needs to be 3. All right, fingers crossed this works. Or not. Learning opportunity if it doesn't. Okay, we got a panic from instance new called option unwrap on a none value. Okay. So I'm guessing this none value is... Where did I define it? Ah, here. This is the none value. Set it to 10 for now. See, is this an int? Okay, it's a uint. So I can't set it to -1. Ooh, there actually is a wasm limits max default. So we're gonna use that. Just hexadecimal max value. Importing environment memory, incompatible type, expected memory type with a minimum of 17 pages, maximum none, shared false, but received memory type maximum 1, minimum 1 pages, maximum none, shared false. So so we probably need to check what the minimum of this is, and then make sure our memory limits matches that. So for now, we'll just manually input 17. Though in the future, we'll want to figure out a better way to deal with that. Alright, what is it complaining about this time? Instance memory. Oh, this is when we're trying to grab it from the module, but it no longer exists as an import. So we'll just delete that line. And look at that, all our code works. Using a not shared as specified in the module. Not module, when we instantiate the memory. We set it to not shared even though we fully intend to share it. I think shared memory is like a different type though. But our modules now import their memory instead of exporting it. So Somehow success. Somehow. The memory got imported. I guess the next step in the process would be to allocate something in one Rust function and then send it to another. So that means yeah. For sure. In fact, there was some stuff in those whatchamacallit. There was some stuff in those forums about them possibly overriding each other. So we'll see if this actually works the way we hope it do. But for the allocator, we do have these globals heap end and heap base. Data end and heap base. So hopefully these get set by the runtime to be different than other modules. So that they don't clash with others. Because that's what I'm hoping happens. So let's see, what time is it? 00:37? Do we import another module? I think we import 2 modules. Oh joy. This is already becoming very unmaintainable. So I'm going to do some quick abstraction to make this a little bit easier. Yeah. So right away, we're gonna have a static WASM module that returns from a file. We just take a string and we're going to grab okay, this is just testing our Rust bindings. We don't need to worry about that. File stream, cpg. Okay, we don't need this print. So you're gonna read it from this file, and then we're gonna call so that just happened as okay. So we're gonna ask for a WASM store type So grab that. We'll grab all of this error checking code. As well as the code to clean up our memory. That's probably important. Yes, if we're going to return invalid modules, we'll have to also check bool is valid. Hello, how's it going? So then after we pull it in from the file, nice. I'm currently bashing my head against the wall, which is the semi-working WebAssembly standards. And the semi-working implementations. It's always fun when you put a ton of work into something for it to just not work. I was nearly there with this, and then I found some random build script variable I could pass that would actually get it to work. Thankfully. What are we doing next? Next, we're building a... This is relatable. Say output, and then we return the output. We're also going to create a standard unordered map. Actually, can... Okay, I don't have Robinhood installed to this particular build target. So we'll just use regular unordered map for now. Going to say an export. We have the index of the export. Let's say this is a UN32. And we'll also have a wasm extern type. Yeah, well, you get used to bigger projects. I mean, it started out as a small project, so it's, you know, slowly cooking the frog and all that. Okay, so export types, exports, this all looks good so far. Actually, let's read imports first as well. Struct import. Then I think the imports should probably be a vector. So we'll say name, and then see, what was the enumerator? Because we can actually use, yeah, extern kind. So we had function, global. Is this imports? It is imports. Yes. We're just going to convert this to something a little bit easier to work with. Once. And then do we want to store the name both here and there? Well, we're going to be using the name to try to find the export. Because usually you want, you want to find a function. So you ask the function name. Then we get the index of whichever export is the actual function. So we're actually going to set this at, well, we can do func by default. Make sure we initialize all these by default, because that just makes our lives nicer. Then let's do imports first. So we're going to just copy this whole disgusting block of code here. Import types. Dot name is equal to hey man, lower level stuff is fun once you get used to it. If you like challenge, this is definitely very fun. I would say that I'm having fun right now. It's frustrating, but I would say I'm having fun. Because there's like no documentation at all. I am trying stuff, and then I am very surprised that it is working as much as it is. You know, it's the type of coding you can only do at 1 a.m. Alright, let's do name first. So we're gonna grab the name from wasn't important. Okay, we probably have to move this up here. So this is our import. say imp type. It's a terrible name, but we're going with it. So we have our import name is equal to, can we just say C string? Okay, we can assign a string to a C string. Though some of these have been a little bit wonky, like they've had extra bytes on the end, so we're actually going to go the entire mile and say this is a string with name data, name size. So hopefully we no longer get weird characters on the end of our names. So now we want the import type. The import type. And then we ask what the extern type of the import type. So I'm trying to create what I'm calling an asset streaming, actually type, we want kind here. So I'm building what I'm considering to be an asset streaming game engine. So the idea is that you download the parts of the game you're in as you're playing it. So let's say I built an open world game in this game engine, or even something like, probably what it's more so going to be used at first is, like, let's say you made a VR chat house or whatever. You'd only need to load in whatever room you're currently in into the engine just over the network or from your hard drive. I've been thinking about making local build support as well, because it would literally just be like running a local server or whatever. But anyway, so you only load in what's like currently around you, just piece by piece. So in any like 80s movie where, you know, you drop into the Matrix and the world kind of like expands out from you, that's like the main inspiration for my engine, is just that one image of you drop into whatever holodeck of environment, Matrix environment, and the world just kind of expands out from you. To what type of game I want to build with this, I'm making it a VR focused engine, since very into VR, and also hopefully eventually open world, so I need like a big team to do that, funding, all that good stuff. So I have different things in the background on how I'm going to get there, but for now, this is just a fun side project I do on the weekends. I used to work on it like for at a minimum 2 hours per day, though unfortunately I have a real job now and signed legal documents, and a co-founder position, but that takes my time away from this, you know, my true passion. No, I care about my job too, but but yeah, this is kind of like, this is my long-term plan I work on in the background. So did I Control X this? Okay, no, that's still down there. I want to drop this into a display function instead of directly printed out from this function. So we do want to store the most basic form of this. So we're going to say import type. Ooh, very nice. I mean, that's more than any of my long-term projects have been bringing in. My website's Patreon did at one point get up to 60, but not for long, because I'm not too consistent posting on it. And I basically never post on it anymore, so the Patreon dropped off to like, it's probably like $10 a month, or something like that, if that. Though it's also for my YouTube channel and whatnot. Doesn't matter too much. I think I want this to be wasm extern type. I think I still want this to be extern type. We'll see. So now we'll do the same thing with exports. Oh wait, first, we actually need to add this to a vector so it exists. Ooh, it was so close. Okay, so we want a export type, not an extern type, we want export type. We'll just say insert. All right, Copilot, you did a decent job. It's pretty good. All right, so now we load a module from a file, and we make it a lot easier to deal with all the imports and exports. Like, a lot easier. So I like that. So now let's implement we'll have a print metadata function, which will have do these things. Oh. Okay, and I should probably have those delete functions in... Actually, no, we're fine. Export type vec delete. Am I calling this on... So do I still need to call this on? I think I do. Oh, this is print metadata. Delete export types. Let's do import types. Oh yeah, right, because this just has a raw data pointer. So that is pretty important. Port types and export type. Alright, less memory leaks there. I'm definitely gonna val grind this entire thing. Eventually. Make sure we're not losing anything. So we print metadata. We should probably not have so many copied switch statements. Oh, that's disgusting. Hey, we'll deal with it for now. Quick refactors, people. Upgrades, people. Upgrades, people. Upgrades. I also do want to come up with a binding for this, like a macro or a generic to be able to handle that. It's not too important. It's like I didn't want to replicate all this code for multiple modules. That would have been absolute torture. So I guess what we want to do next is standardize a way to get imports. So I'm just going to create a it's literally just going to be a map. Yeah, we'll just make this be a local thing. So we have our engine, we have our store, we have our instance memory, and then we have our imports. Where is my previous definition? Ah, there. We'll call this imports map then. We're going to say test external function imports map insert. Ooh, Copilot's starting to pick up on stuff. So this is our test extern function. Yep. Then I think I called this extern BraneEngine print. So we add all of those to the imports map. We also want to insert memory. This needs to be a set. Sorry, a pair. So now, okay, for now what I'm going to do is call this an import map. We're going to type def it. That is exactly what I wanted. And then what we can do is when we are in need of this import object, we can say, and what was the data type? Wasm extern vec t. Build import list. And into here we take an import map reference map. And we're going to say wasm extern vec t output wasm extern vec new uninitialized output, not map size, we want imports size. And then for import and imports, we want to actually, let's do this with indexed for the, because we need to access output. So import equals imports I. We're going to say output data equals iterator second. That's actually perfect. Except for this, which is a failure. And we'll eventually need error checking and handling there, but nah, for now this works. So down here, we would just call build import list. And that would build our import list. There isn't... is there a better way to make calling functions easier? Yes, there is. I can pull over some of the stuff I did for SQLite, which I'm pretty proud of. I'm pretty proud of the template functions I made for that. But for now, we'll just manually write out the signature for everything we want to call. It's a lot easier to find the extern now, though. I think those were the main pain points, though, so let's convert this over to our new system. So after we generate all of our stuff, let's actually create some modules. We're gonna say auto module 1. What did I call them? Wasm create. Wasm create 1. Oh, there we go. So we get both of our Wasm crates. Going to say instance 1. If not instance 1, we're going to say Wasm create 1 dot module. All right. So this now theoretically that now instantiates our first instance. And then let's also instantiate module 2. Keep the same instance air. We'll say imports 2, instance 2, if not instance 2. We'll say imports 2 and crate 2. And we also want to do crate 2 build import list. 2, 2, 2, 2, 2, 2. Looks good. And we need a better way to get instance exports. Externs 1, we'll say instance 1. Externs 1. We'll also do this for 2. And we're gonna say externs 1 data wasm crate 1 dot oh, I want this to be exports. At test function index, because we do want this to throw an error if it's not there. And then this one later. Should probably put this in the destructor of our WASM module. That looks good. Okay. Let's just check if this works. It's gonna fail because I haven't copied the actual files yet. This module, oh, the module's actually something. The module should be null pointer. That's concerning. Do I have module 1 or module 2? No, I just have wasm crate. There we go. Failed to open a wasm file. Oh, I wanted this to be... Oh. I wasn't using the correct path. Okay. Now, let's actually copy over wasm crate 1. You don't need to show me it. And wasm crate 2. Alright, so we have both our wasm crates in there. is erroring out here? Illegal instruction operand. Wow. That's a new one. Illegal instruction. Failed to find import. Test external function. Oh. So I have it called test external function, and then I just went with Copilot there. How's it going? We have this is test external function. And then this I did confirm was correct. And then memory is just memory. Okay, let's compile this again. As you do, as you do. That is the only way to play Skyrim. Aside from the first few playthroughs. It's still this same place right here. Map 0. Okay, let's put a breakpoint here. So why is our map size 0? That shouldn't be the way that it is. So we pass in imports map, which should have these two things imported into it. Should have this. Place a breakpoint there. This breakpoint there. And yeah. Imports map should have more than 0. Okay. Even though import map, which is just an unordered map from string to wasm extern, is just not showing up in the debugger. So it finds it, so it's claiming there is stuff in this map because it's actually finding stuff. LLDB broke. And then that just breaks. Legal instruction operand. So we're just gonna say output.size. Oh, it's not a. So I know that does something. I also know that does something. Two, three. And then it panics. Or errors. Or whatever you want to call it. Indeed. Why angry? Alright. This looks like a job for Valgrind. Tell me where the broken error comes from and where the broken memory goes. All hail Valgrind, solver of all memory leak issues. Runtimes of eternity. Is probably your program's fault. Oh, joy! Oh, joy. Your program just tried to execute an instruction that Valgrind did not recognize. Your program has a bug and erroneously jumped to a non-code location. And saw a warning about a bad jump. It's probably your program's fault. This is the most basic of for loops, my friend. Oh, joy. So we don't need to worry about RTLD Malik. One byte. Wasm Funk New. Okay, yeah, I'm not cleaning those up at the moment. That's a good thing to look at later. The module wasn't cleaned up, probably because the program crashed. So, yep. Why are there so many module from file? I guess there might be multiple allocations that go into that, and they all happen in this new call. Conditional jump depends on uninitialized val. That's inside the parse. Oh no, Valgrind is saying that something in Rust is depending upon an uninitialized conditional jump or move depends on uninitialized values. So what I'm going to do is delete our binary and just compile it again because it looks like something got corrupted. Wasn't that? illegal instruction operand. Oh, it's the divisions for theirs. What's my program doing? Oh joy, so we've somehow come across a compiler or something. Wow. I'm gonna try doing something weird, like switching out the map library we were using. Fidelity. Would this include Robin Hood? It would. Then in WASM, scripting tests will include Robin Hood. Include directories. Okay. Then back in here, Robin Hood is fine. And then we're gonna say this is unordered map. Do you think that will change up our binary enough? Let's see if it does. Same error. Okay, let's try bundled GDB instead.
Oh, wait a second. I wasn't returning it. I'm dumb. Is that our bug, though? Let's go back to indexed for loop. Maybe that's why it went from 10 to 3 viewers. It's because they were like, oh, this guy's an idiot. Can't return from a function that we expect a return value. This is the most cringe thing I've ever seen. Look at that, different error. That was it. All right, so get a segmentation fault. On WASM module. Okay. Output. We do set output module to module. So this module is created correctly, I think. Can do this before the error check. All right, let's see. So store is probably whatever store was. WASM module is... That's a lot of 5s. A suspicious amount of 5s. Imports is probably fine. That's a lot of 5s too. Segmentation fault. This is on module 1, which means should be fine. You say WASM instance new, store, create, module, imports, and a reference to an instance error. And we return a pointer to a pointer. So I'm assuming... we'll just do null for now. It might be trying to access that, but we're not passing it what it wants. I would assume that it was going to set the pointer to something, but we can just use this last error. That's error. So it wasn't that. Segmentation fault. Module info. Alright, am I missing a step somewhere? I don't think I am. Going to set this to 30 by default. Say WASM module new. Let's check that we're not create new store, new module, wasn't bytes, adding say hello to imports, instance exports, run function call. Not using any of those anymore, so we don't need them. We find all the imports. All right. Maybe it's something to do with this WASM ArrayVec. But I'm calling their functions for instantiating these. It should be fine. Say wasm extern vec new uninitialized, by which I assume that just means all the data is uninitialized, because you're not getting null pointer access errors or anything. So, I would assume that this import list is, working. Yep, out. Then a size type, which is probably the size. Wasm instance new. Okay, so it's something to do with the module imports. Create one module, imports one. That all looks correct. This I think we can actually val grind though. Possibly. We shall see if the almighty Valgrind shall grace upon us a bug report of usable code. Inside of a freed object. Something to do with crane lift. So this should not be a Stack Overflow. An initialized value was created by a stack allocation. Wasm crate 1. Okay. Should have gotten an error to the console if we did either of those. Interesting. Well, that's the same panic. Wait a second. I bet I know what it is. The pointers we're referencing in here are tied to the lifetime of this vector. So it would be super dumb if it was the issue. If so, that could mean that we're passing. We don't use it anywhere though. Import type vec delete, import types, and export types. Then in this print, we no longer need to do that. I don't know if I think that's the issue. It wasn't. Dang it. This isn't telling me where it came from. It's happening on imports 1, which means it's not an issue with it's not an issue with us trying to allocate 2 modules. Or is it? Nope, it has nothing to do with us allocating 2 instances. We have our module, our imports of memory, import types, size 0, data null, export types and exports, heap base, data end, component access, that's all good. That's all it's supposed to be. So why it no work? So right after wasm instance new, module imports. So it has something to do with the inputs. Just... Okay. What? No, that wouldn't be it. The only thing I can think of that's different for this function to the original is that we're manually creating this output. New uninitialized. I've used uninitialized before and it's been fine. Now if I said if I just did that, would we get the exact same error? We would. I am. Let me check. Yes. Just past 2 a.m. We do some late night coding. Import type and export types. That's what I'm doing. I'm initializing them. Still getting that. Well, I probably have my weird force the error. Ah, yeah, that's right. They don't have names. I don't know. I stream and people watch. I don't know why. Maybe it's the music. Maybe they find what I'm doing interesting. Be honest, I don't know. I find it fun to stream, so I do. And that throws an error. If I knew what value is trying to ask, but value is trying to access, I'd be able to figure this out pretty quickly. Well, we can run wasm file validate. See, this worked just fine before. What has changed? Oh, we shouldn't delete that. That was one of the things I thought might have been causing the error. It's not what was causing the error, but it's one of the things I thought could be. This is the only thing I can think of. So we're gonna say wasm arrayVec. But we can't use that on anything that's not a fixed size. Allocation of incomplete type. Also extern. So we can do another pointer. Do imports size. Output I, and we can just say out, then the size. Then an array of the type. Like that. Doesn't make any sense.
code isn't any different. I don't want with coverage. Well, I didn't change anything. And now it's working? Okay, so apparently we shouldn't delete these instances. Really doesn't like that. But if we just run this normally now. Oh, it's still getting, so it sometimes works and sometimes doesn't. Because it worked there for a second. Yep, so same error for release.
Okay. What if we did imports the old way? Said test function. Exports, reading exports. Import empty. Ah, here we go. Okay, what if we just do this? Does that work? It does not. So something to do with how we instantiate the module. Module new. Module equals module. Is there anything else? Yep. Store new. Do instance. And that's literally the whole thing. Okay. I'm nuking the build directory. Same error. This was all working before. Of course. So for some reason, it's now working with Valgrind, but when we run it normally, okay. Now if we go here, or here to tool chains. Okay, so that's an invalid free. I think they're all module delete. Okay, so nothing to be there. Invalid read. Resolve imports under module instantiate. Wait a second. Don't tell me. Oh, brain just... I just caught on to what might be happening. So we have this WASM module, right? With a pointer to our module. And when we copy this out of this function, the destructor runs. And it deletes the module. So what we're going to do to just quickly get around this is say WASM module equals delete. No copy constructor. Forcing us to call standard move. But we do have a move constructor, which should work just fine. This should also work implicitly. Yep. Which means the code will now work. Or it will not. Which means I do have to implement a move constructor, don't I? So when we move this, call move, we equal and other module equals null pointer. There we go. Now it works. It was that simple, but yet that opaque. This is why we use Rust, people. Okay, let's fix this other error and then I'm going to sleep. So, parameter of type supports at test. Oh, we want this to be test function 2. Test extern call. And there we go. The abstraction that was supposed to speed stuff up and get this working by the end of the night instead paused us for like an hour and a half. Anyway, we now load 2 modules. I'm going to very quickly attempt to call a function from the second module. Externs to create 2 exports dot at create test component
So we're going to call create test component. This will see if I can move this in here and have it be fine. Can. Alright, this creates our test component and returns it. Then in test struct 1, we have test component access, where we modify the component and then return it. So what we are going to do is compile this real fast. We grab this and that. Drop it in here. Then back in our WASM scripting tests, we're not gonna test component access first. First, we're going to create component. Okay, so it is create test component. Component. And we'll keep it for now. No, OCD is kicking in. Component, which means we have to recompile this. No arg values, but we do get one result. Test component equals, yep. Okay. Now, go back to crate 1, where we test what did I name it? Test component access. So now we have one argument, which is int 32t test component wasm pointer, and we're gonna set that to that, and what we're gonna pass into the function is the test component wasm pointer, and the value we want back should be the same thing. And also we get our values after access. In fact, I'm not gonna assert that because I don't want to deal with, yep. All right, let's see what this does. Parameters of type I32 do not match signature I32. Okay. Oh, we want externs 1 test component access. Externs 2 shouldn't have, oh well. It works.
So, to recap, we have WebAssembly. We have 2 separate built WebAssembly modules. Both of them are written in Rust. We have our own custom attributes we put on them to make them expose themselves to the runtime. What we just did was create a component or a struct. We allocated a struct. I'm calling them components because we're going to be using this in ECS. But anyway, we create a component. We return it outside of the runtime. Well, we return a pointer to it within the WebAssembly runtime. We return that pointer back out to our testing framework here. We store it in this value, and then we pass it into the other loaded WebAssembly module, and that WebAssembly module was able to access it. Which means I can actually use this as a scripting system for my game engine. We have all the pieces we need right here, and all that's left is just to actually implement stuff. We have proof of concepts for everything we need. Anyway, it's 3:01 a.m. I'm going to go to sleep. Thank you all for watching, if you still are, and I'll see you next weekend. I don't know if I'll get a stream in tomorrow. Dinner with family. So, we'll see.